All right, Patchen, thank you so much for joining us here tonight.
I'm glad to be here. Thanks for having me.
All right, so we're going to be talking about your book, The Impossible Man, Roger Penrose and the Cost of Genius. I read it very avidly over the Christmas break, and I came up with all sorts of questions to ask you about it. So.
Okay.
All right, so maybe the simplest or the first. Why Roger Penrose, and why now?
So it's a fair question. So the now is a little bit complicated because the book took 6 years to write, so now at the beginning is not the same. But Penrose is one of the most influential researchers in relativity and cosmology of the past century, easily. Some people call him the most influential since Einstein came up with the theory of relativity. And I was aware as a science journalist that there are multiple biographies of Einstein, of Hawking, and many other biographies of prominent people in the field. And it felt like a very odd gap to me that Penrose hadn't had a biography written. I mean, he is still alive, and not just still alive, but still actively working as a scientist as well, publishing, lecturing, debating. But even so, his influence was great enough that it felt like that on its own warranted a biography. But the other thing about it is there's something very unusual about Penrose in that his work, both as a scientist and his the other parts of his work that he's famous for, mathematical puzzles and games and creative things, all of it is connected by this really unusual visual beauty. And this is something that I had been fascinated with for a very long time. And all of those things made me very curious about how he came to accomplish that great variety of absolutely beautiful work. So that's kind of where it started.
Yeah, amazing. Yeah, we'll get into both the puzzles and the relativity. But it sounds like you saw a real opportunity there for a new biography of this very influential scientist. Mm-hmm. What steps led you to approaching Roger Penrose with the idea of a biography, and what did that process look like?
So my introduction to Penrose's work was actually not the science side. It was Penrose tiles. It was his optical illusions, like the Penrose triangle, that sort of thing. So I first knew him there, and then as a scientist, as a science journalist, got to know his work around black holes, the work that ultimately won him a Nobel Prize. And just by pure coincidence, I worked on a project called the Gravity Archive that was a multi-university effort to digitize the unpublished papers of some influential physicists, starting with Penrose. And through that, I got to know some of the work in his notebooks and that sort of thing. And his notebooks are full of compelling, beautiful drawings, and you could see little indicators of how, a half-formed idea and that sort of thing, which was really an exciting kind of insight. And also through that project, I first met him at a conference in Vancouver, and then approached him some months later about the possibility of working on a biography, and it just kind of grew out of that.
Wow. And what was his initial reaction?
I mean, he I think agreed that his life was worth examining, and I think that he, like anybody would be, was also, I don't know if nervous is the right word, but cautious about how that might proceed. Mm-hmm.
And so that requires you to develop quite a lot of trust with your subject.
Right.
What did that look like for you?
So, I mean, the way I would describe that, I guess, is we began doing interviews, like just to see how it felt and that sort of thing, and. As a journalist, as a science journalist, I'm very used to interviewing scientists, and so we began talking mostly about the science as we went. But it was because the project took so long, it really sort of grew and evolved over the years. But it was always a matter of each of us trying to be as direct as possible with the other, I would say.
Yeah. Okay. So it sounds like you were fairly familiar with, the scientific side of his life before you took on the project. In the process, you got to know more about his personal life, mm-hmm. And I think that was a very interesting side of it that I want to get into as part of the interview, perhaps a little bit later. But just in terms of, how much of his personal life were you aware of before you started the biography?
I mean, almost none. I knew some stories that when we had first met, that he had told me stories as people do when they're getting to know each other, but I didn't know that much. And I think that what I was interested on that front, physicists have, as a rule, they have unusual relationships with concepts like time and gravity. And I was very interested in the interplay between sort of the professional relationship to those concepts and the personal relationship to those concepts, because it's something that I'm just deadly fascinated with, is, if you understand that time is not at all how we perceive it, how does that affect your approach to life, aging, deadlines, all of those sorts of things. So that was kind of where the personal side of it really started to grow for me.
Was deadlines an issue as you were?
Deadlines and mortality are two things that I have fairly major issues with myself.
Right, okay. Right, okay, so I want to dig into the physics, because, I think first and foremost, many of us think of Roger Penrose as you said, a very distinguished and very famous physicist.
Yeah.
And in the book, you talk about, the many physicists that he collaborated with over his life and the work that he was doing. Can you first just speak a little bit about the research that he really was doing as his most famous pieces of research?
Sure. I mean, I think the most famous is probably the work that he won the Nobel Prize for, which was around black holes, and a little bit of the story. So when Einstein first created the theory of relativity, it came with a pile of equations, and those equations could be used to make various predictions about the way the universe works. And testing those predictions were a part of testing the theory of relativity. But one of the things that the theory predicted was that it was possible for mass or matter to collapse gravitationally to a point of no return, where it just keeps getting smaller and smaller and denser till you reach a point of infinite density, and that was called a singularity. Every physicist who understood the theory of relativity recognized that that's what the equation said. Almost nobody believed singularities could actually exist in our physical universe. Physicists don't like infinities. I don't mean to speak for any physicists here, but it's something that often, if your equations go to and give out an infinity, then it probably means there's an error in your calculation somewhere. So singularities were a prediction of the theory of relativity, but most people thought, sure, but that's just the math, not the physics. Then, with the advent of radio astronomy in the late 50s, there was a discovery of what came to be called quasars, which showed every sign of being incredibly high energy, and very small distant objects. And they showed every sign of perhaps having a singularity at their center. And so a lot of people started to reevaluate, well, could we be wrong? Could there actually be singularities? And there were people all over the world in the late 50s and early 60s trying to come up with a theory either to prove their existence or to prove that they were impossible. Most people were looking for kind of exotic circumstances. If you have a perfectly symmetrical cloud of gas that there's no chaos or swishing around, maybe that could do it. Or there were other models that people thought would be possible. Penrose went the opposite route and looked for a general solution, something where you needed very few conditions in order for a singularity to form, and he found it. So he published a paper published in 65, I believe, 3 pages, some diagrams, very few equations, and that was the paper proving that singularities existed. There was a lot of debate. There was some very interesting intrigue over the debate about whether he was correct or not, but ultimately he was vindicated, and in 2020, much later, was recognized for that work with the Nobel Prize. So that is the thing he's most famous for, but he also has been hugely influential in the much broader effort to write and rewrite the story of our universe, how it began, why it is the way it is, how it might end up. He's been he's helped set the agenda for that research for more than half a century.
And I think one thing that kind of surprised me in your book, so I think of Roger Penrose as who works on black holes. I think of it in terms of radio astronomy, these theories that relate to observations. But at his core, he sort of describes himself as a mathematical physicist. It's a very technical subfield, very math heavy, as the word suggests. You are not a scientist. Is that correct?
That is correct.
Okay, and so approaching,
Very correct.
I understood the concepts in the book very clearly. I thought you explained the physics extremely well. How is that process for you? What is it like to explain these extremely technical and very difficult to understand concepts in a way that, when I'm reading it, I can understand what's happening?
Yeah, I mean, I work in general as a science journalist. I came to this through my work as a science journalist. And so it's a challenge that's not just for this book, but it's in almost everything I do, where I am talking to people who are elite experts in their field about highly specialized work. And Penrose is no exception on that front. So it is a lot of, I did, of course, read his papers for what that's worth, but I'm not reading them as a physicist. I'm not a physicist. I don't have the training in order to do that. I was fortunate to be able to talk not just to Penrose, but to other scientists as well. And I feel like the role of a science journalist, and in this case the role of a science biographer, is to kind of be a bridge between the true subject matter experts, the scientists, and the people who would be reading the book. So my job isn't to become a physicist, but it is to be able to understand the questions that people are trying to answer, the potential, the field of answers, where those could come from, and also not just to help make that understandable for myself and for readers, but also to make it relatable, because you can make it as understandable as you want, but if it isn't humanized, if it isn't relatable, then I don't think that people will make the effort to try to understand it. So a lot of it comes down to storytelling. It's about the journey of discovery as much as it is about the nuances of the science itself.
And I think maybe related to the actual research itself in the math, Roger you mentioned in his notebooks a very visual, very really diagram heavy, really a lot of sketches and things like that. I was wondering if you could just say a bit more about the role that visual storytelling played in a lot of Roger Penrose's research and work.
For sure. I mean, Penrose did. He trained in algebraic geometry, but at heart, I think of him as a geometer, someone who is dealing with the shape of things. And his work, he often collaborated with people who were more on the algebra side, people who were more about equations. But if you look at his work, it's not just that it's visual, it's also that it is elegant. It is something where if you look at his diagram of a singularity, or you look at a space-time diagram, which is another one of his great innovations. All of his work has this kind of grace about it, where even if you can't fully grasp the scientific concepts that it is so powerfully depicting, you can still just appreciate the connection to this kind of underlying mathematics of the universe. There's something beautiful and compelling about it. That kind of visual storytelling comes out in many aspects of his work, not least of which is, one of the things he's really well known for is, until recently, he greatly resisted moving to PowerPoint. And he used acetate overheads that he drew himself. And it wasn't just that they were graceful diagrams, but his presentations were performances of visual storytelling. So he put out a diagram of the history of the universe, and then lay another acetate on top of it to tell a story, or turn it upside down and all of a sudden it's telling a different story because time is reversible, or making a point that way. There's something, I mean, I think that's one of the ways that he became not just this influential scientist, but also someone who had a huge public profile, has a huge public profile. He's known well beyond academia. I think part of that is because of the visual grace of his science.
Did you get to interact with those transparencies quite a bit?
I did, yeah. In fact, I got to watch Penrose present with them, and also got to sit down with him and talk through some of them, get his thinking about how he created them and how he uses them and that sort of thing. Total privilege.
Wow, amazing. I think related to this grace and this beauty that you're talking about, one of the things that you hit on in the book, and that maybe is not a surprise given the title of this evening's event, is this idea of unexpected simplicity and the ways that it shows up, not only in mathematics and physics, but also in art.
Yep.
Can you say more about that idea?
Yeah, sure. So the term unexpected simplicity came out in a talk and a paper that Penrose gave in the 1970s. I'm not going to be able to remember the exact year. And he was talking about Penrose tiles in that speech, but it was something that read like a kind of manifesto about his approach to both mathematics and science. And it is this idea that a problem can look incredibly intractable and complex and difficult to solve, and sometimes with a little shift in perspective, it suddenly becomes simple. And if you notice a possibly simple explanation for something, it's not quite Occam's razor, but it is an idea that if there's a simpler way to see things, that might be the path toward discovering an important new insight. And you see that I talked about how his singularity theorem was general and simple when other people were looking for these very complicated circumstances where a singularity could form. Once I noticed it in that talk, it was something that I felt kept reappearing at different places in his life from childhood all the way through.
That's a really interesting theme.
Yeah.
You talked about Penrose tiles, so we're going to just jump to that.
Sure. It's a great example of unexpected simplicity.
Exactly.
Actually.
And so that's maybe the thing that I'm most familiar with
right.
from Roger Penrose. Penrose tiles, or this set of tiles. We actually have some tiles out in the atrium for folks to play with after the event. So maybe could you just explain a bit to us in simple terms the Penrose tiles?
With pleasure. They are the thing that remains my main fascination as well. So I'll give you a little history of tiles, a little history of a specific type of tiles. And these are tiles that can cover an infinite plane with a pattern that never repeats. It can't repeat. There's no way to put the tiles together so that they repeat. And it is an idea that originally, when people talked about it, it was another thing that people thought was impossible. You can't create a finite set of tiles that will cover the plane. You can use multiple copies of them, but you only have so many types of tiles that will cover the plane with no gaps, no overlaps, in a pattern that can't repeat. This was a theorem originally put forward by a mathematician named Hao Wang, that this was impossible. He had a student who tested the theory and eventually determined, no, in fact, it is possible. You can create a tile set that is what's called aperiodic, has this non-repeating pattern. And once he figured out that it was possible, he created a set of tiles. They were squares, and the squares were a different color on each side. And the tiling rule was you had to match color to color as you were doing them. And he figured out, I think I'm going to get the number right, a set of 20,426 tiles, squares with different colors on them, that created this aperiodic pattern. No matter how you did them, you could keep going with the pattern, but it would never quite repeat. Once that was possible, many mathematicians, including the student, his name is Robert Berger, tried to find smaller and smaller tile sets that were still aperiodic, and people got it down under 20,000, eventually got it down under 100. There was a set that was 11, all of them based on squares with different colors, or almost all of them based on that. Roger Penrose entered this world of aperiodic tiles in the early 1970s, and he had noticed the logo of a university that had invited him to speak. The logo had in it a pentagon, a five-sided figure, with 5 more pentagons appended on it to make kind of what looked like a flower with petals that were pentagons with awkward gaps. And he was just playing with like, it was something that stayed in his mind. He was playing with these pentagonal patterns. Pentagons are not something anybody thinks about as a tiling option because they're so awkward and don't fit together very well. And he imagined what would happen if he took that 6-pentagon pattern and treated that as one big pentagon and then put 5 more petals around that. And what happens if you make that bigger, or what happens if you divide it? And he found all kinds of jagged gaps between the patterns that were formed as a result. And eventually figured out with that kind of hierarchical, almost fractal pattern, that he could cut up the gaps and the pentagons to create a set of 6 tiles that were aperiodic. And this was, going from more than 20,000 to 6 is itself an incredible simplification. But his tiles were, one was called the jester cap. It was like 3/5 of a 5-pointed star, and there were 3 different types of pentagons and I think a rhombus. In any case, he kept thinking about this, and I know what it was. It was, he had an office mate. He had lent his office to a visiting researcher at Oxford who showed him an article of someone else who'd come up with a different 6-tile set based on squares. And his reaction was, I get mine down to 5. And because he knew the 2 of his tiles always fit together the same way, he just didn't make it 5 because it wasn't it was kind of ugly. He got it down to 5, very quickly got it down to 4, and then came the real stroke of unexpected simplicity, which was that he cut up his tiles in a different way. And he created a tile that was just a rhombus. He called it, or it eventually became called the kite, and then a rhombus with kind of the bottom tucked in, concave, and that became known as the dart. Both of these were shapes so simple a kid could draw them. The 5-axis symmetry of pentagons was hidden. They both just looked like bilaterally symmetrical shapes. Incredibly simple and still aperiodic. So I think that was in 1974 that he created the kite and the dart, and there have been a couple other versions of Penrose tiles. And that record of 2 aperiodic tiles of incredible simplicity and unexpected simplicity, that record stood until 2023 when someone came up with a single tile that is aperiodic.
Oh my goodness. Can anyone do it in less than 1?
Well, I don't know if you can have 0 aperiodic tiles.
There are many times in the book where you talk about these sort of flashes of inspiration and these sort of strokes of genius almost that Penrose experienced throughout his life. Many of those happened in collaboration or through conversations with other scientists, where he was really the one who made this jump or this leap towards this new way of formulating something or of explaining something. But really, he found himself in collaboration with a lot of amazing and great scientists.
Yeah.
And I think, there's an interesting back and forth between this idea of, intuitive genius and the very collaborative nature of science. You interviewed many of Roger's peers for this book, and, they describe him as someone with almost superhuman mathematical intuition. And much of Penrose's research and his scientific breakthroughs, came from collaboration. So, in talking to Roger Penrose, did you get a sense for the role that these 2 things, collaboration and intuition, played in his own view of his research?
It's a great question, and it was another of the motivating factors for the book. Was when I spoke to other scientists, you are absolutely correct that they would describe his work. The word that came up more often than you might think is magic. There's a very powerful quote from one of his colleagues, Rainer Sachs, a great physicist, talking about how when he looked at Hawking, he felt like if he'd been a little smarter, if he could work a little harder, he might have been able to do some of the work that Hawking did. But when he looked at the work that Penrose did. It seemed to just come from an epiphany. It seemed to be superhuman in where it came from. So I was very interested in trying to track down how those flashes of brilliance came to be. And there's no simple answer to it. I know we're talking about unexpected simplicity, but there isn't, because there were moments. There were moments with Penrose tiles. There was a moment, Penrose tells a story about the Penrose singularity theorem, where he'd been working on it for a while, thinking about it, as many scientists had. And then he was out for lunch with a friend talking about completely other things. And they were on their way back to Birkbeck College, where Penrose worked at the time. Crossed the street, and as they crossed the street, they stopped talking because they were concentrating on crossing the street, a few seconds. And in that moment, that's when he solved singularities. And then immediately forgot about it. But then couldn't figure out why he was in such a good mood, and so then went over his day and remembered it again. So there were these flashes. But you can't separate that from both the incremental work that it takes to do science and the collaboration, the conversations, the trading of ideas, and that sort of thing. So I think both are true. I think that is maybe a contradiction that we have to live with, that you can have these flashes, and it's really hard work.
You brought up Hawking, and I wanted to ask a question about the relationship between Penrose and Hawking. They published several famous papers together, and were close collaborators for a while, but it sounds like it was, from reading your book, it sounds like there was a bit of a complicated relationship between the two physicists.
Yeah, I mean, it's interesting because I feel like there's kind of a motivation to make them either great friends or great enemies and that sort of thing. And I don't think either of those things were actually the case. They were definitely colleagues. I talked about Penrose's visual sense. Hawking certainly shared some of that and also had great facility with equations as well. The work they did, they didn't do as much work together as people often think. It was a couple of very influential papers. They did certainly work in the same area. And I think, early on when they were first in very regular contact with each other, they were certainly, after the Penrose singularity theorem was established, Hawking built on that, flipped it around. So Penrose had figured out this point of infinite density where space and time come to an end moving forward. Hawking flipped that around and theorized that the universe itself began in a singularity where time began, using similar mathematics. So there was a time when they were very productive, feeding off each other. I think that there was something of a perception, maybe on Penrose's part, that he came up with the Penrose singularity theorem. Hawking took it to places he didn't expect, that Penrose hadn't thought about it, and this happened with a couple of other ideas as well. But that Penrose was the originator of the truly revolutionary idea. Later in both of their careers, they really diverged intellectually. And sometimes that gets played up as more of a personal conflict, but really it was about ideas. One of the biggest things that they ultimately ended up disagreeing about was whether information gets destroyed in a black hole or not. Penrose has no problem with information being destroyed. And Hawking and many, many other scientists have a big problem with it. And I sometimes try to convey the significance of that disagreement, like what it would mean if information is destroyed. It's something that's fundamental to understanding of the nature of physical reality. I won't delve too much more into that. But in any case, they diverged intellectually and ended up, they had some debates and that sort of thing. But all of it was, I think all of those differences were still on a very professional, scientific level.
Yeah, they disagreed as scientists.
Exactly, yeah.
So I want to switch gears a little bit and talk about the other half of the book, I would say, that's sprinkled between the science. I think you made a very intentional choice in the book to balance about 50-50 really between Roger's really incredible physics and the challenges of his personal life and his personal relationships. in writing a biography of a physicist? What made you choose that sort of balance?
A couple of things. One is, when people, often when people sort of challenge the idea of a lone genius, what they talk about are colleagues and predecessors, the other people who contributed. And I think that's a big part of where genius comes from. But I think that there are a lot of other people that are a part of that story that maybe don't typically get included in a work of science history. And I was very interested in those aspects of things. I was also, as I said at the beginning, I was interested in the interplay between personal and professional relationships with time and space and gravity and all of those sorts of things. So for all of those reasons, when I was telling the parts of the story about his personal life, I was trying to do everything through the filter of how did his science affect those relationships with other people? How did those relationships with other people affect his science? And that was really what I wanted to try to get at. Coming back to the idea of him being seen as superhuman in magic, I wanted to root his genius in his humanity.
That's really interesting. And in terms of his relationships outside of his science, I think there were actually many of his personal relationships that really blurred that boundary between the science and the personal.
Yeah.
Can you say a little bit more about that?
Yeah, sure. I mean, I think that those stories start with his childhood, where one of the major ways that he bonded, especially with his father, but sometimes also with his brothers, was through science and mathematics. It was one of the ways he could get approval, get attention, and get affection, I would say. And I think that was something that stayed with him through his whole life. And whether it was with friends or romantic partners or with family members, a huge part of the way he connected to people was through the incredible joy and beauty and sense of discovery that came with his science and his mathematics. And, well, actually, I'll just leave it there.
It's probably going to feed into my next question.
Sure.
I mean, over the course of the book, it really emerged. He had a challenging childhood. He had, some very, I think, cold or distant relationships with his parents, and some very, at times, painful dynamics that emerged in his relationships with the women in his life, particularly, including, his first and second wife, where, an emotional affair during his first marriage. Can you tell us a little bit more about this? How it was to write about this and learn about this and work through this with, as a biographer?
Yeah, I feel badly now that we called the talk Unexpected Simplicity, because all of these things, none of these things are simple. Mm-hmm. They're not simple to learn about. They're not simple to write about. I knew when I was going into the book that I was going to learn about a human being. Human beings, I would say, are not unexpectedly simple. I think being human is complicated and hard, and I think that is part of his story, the way I think it's part of everyone's story. So when I was exploring those relationships, I didn't want to, I don't think it would be fair, and I hope I didn't, portray them as just unequivocally unhappy. Mm-mm. There is so much joy that he was able to share, is able to share with the people around him, but it's complicated. And I think that one of the challenges was, if so much of the way you connect with people is through science, mathematics, discovery, intellect, when you can't make those connections, then things can get very difficult. Mm-hmm. Things can get unhappy. And there were a number of times where that unhappiness became a more complicated puzzle than solving black holes or solving the origin of the universe. So again, when I was writing about those things, I was still trying to connect it all back to these works of genius as I was going through, but I didn't want to hold back either on the humanity of his story. So that's where I kept coming back to. Not simple.
Not simple at all. How did you find working with Roger Penrose on these these topics around his personal life that
Yeah.
factored into the biography. What was that experience?
I mean, to his credit, we spoke directly about the stories that are in the book. And in our interviews, when I would ask him direct questions, I really believe that he answered equally directly. And I think that the result of that is a really unusual level of insight into what goes into an extraordinary career like his.
I want to talk about the title of the book.
Okay.
So I still don't. This is why I'm dying to ask you, because I read it cover to cover, and I still have this question. So the title is "The Impossible Man." Can you tell us a little bit more about why you chose this title?
I absolutely can. It has a couple of meanings. One of them is we've talked about people thought singularities were impossible. He demonstrated that they were possible. He wasn't the person that proved aperiodic tiling was possible, but he was part of that journey. Another of his most famous mathematical creations is something often called the impossible triangle, which is an optical illusion that he developed in the 1950s. So much of what he did it was proving impossible things possible. It was creating impossible things and doing things that people thought were impossible or that felt impossible. The other aspect of it is that if Penrose thinks mainstream science is wrong, if he thinks a theory is flawed, if he thinks there is a better explanation, he's not going to be deferential about it. He doesn't shy away from it. And in that way, that's the other meaning of impossible. He will not make it comfortable for other scientists to just go. I mean, one of the prime examples of that is around string theory, which he has no patience for, and he will not defer. So he can be impossible in that way as well. He can be stubborn.
Okay, that makes a lot of sense. And then the subtitle of the book, I'm really getting into it.
Yeah.
The subtitle, Roger Penrose and the Cost of Genius.
Yeah.
I think it comes out a bit throughout the book what you mean by the cost of genius. Maybe not necessarily a cost as much paid by Penrose as by those close to him, but maybe you can tell me more about what you were thinking with the subtitle.
Yeah, it's funny because I still roll that around in my head a fair bit, because sometimes I think what I'm really writing about is the cost of being a human being. And in some ways that's true, because I think all of us experience trauma and confusion, and we try to figure out how to live our lives and how to love and how to be loved, and there is often a price that comes with the missteps we make and that sort of thing. So I've really tried to think, what am I talking about when I talk about the cost of genius? And I think one of the things about it is, I think people sometimes have a perception that to be a genius, whether it's in physics or whether it's in art or musicianship or sports or anything else, where you're going to be the absolute best in the world, where you're going to change the game, where you're going to do something truly original, all of which Penrose did, that you somehow have to be removed from the people around you. You can't be concerned with everyday things. And that is a cost. It's a cost to yourself, and it's a cost to the people who care about you. I don't know, though, I don't mean to imply that cost is a necessary cost. I don't know that you have to pay that fee to win a Nobel Prize, to change how people understand the universe, to do all of those revolutionary things. I don't know. But anyway, those are the things I was thinking about when I came up with that subtitle.
Really interesting. So as you were writing this book, you said it took you 6 years to write.
Yes.
And you started it somewhere around 2018.
Yep.
And Roger Penrose won the Nobel Prize for Physics in 2020. First, just as an aside, how did that feel as a biographer?
It was, I mean, obviously it was great, but also I had really been struggling with how the book was going to end before that. And of course that changed how the book ends. It was It was so exciting and, to me anyway, unexpected.
Unexpectedly simple, perhaps.
Perhaps, yeah. It did simplify some things for sure. Anyway, it was really neat.
And how was it to be communicating with Roger Penrose during this time? Were you talking to him during this process, or at the time of the award?
Yeah, we were in regular interviews, and I don't know if he knew it was coming, but he certainly hadn't mentioned it to me. And it was 2020, so we were in the absolute depths of lockdowns around COVID and that sort of thing. And I mean, here's what happened. About a week before that, I was up first in my house and making coffee and tea and getting ready for the day. And my spouse came down, she had been listening to the news upstairs, and came down and said, he's got COVID. And I didn't know who she was talking about. And it turned out it was Donald Trump, who was then president. And it was this big, it was I don't know if you remember, but it was a
major
hideous, comic, tragic, awful story. And so then a week later, I was again the first person up, and she again came downstairs and said, he won the Nobel Prize. It was like, so there's a great moment of confusion. And then he must have been 10-year-old or 11-year-old son came, no, he was even younger than that, but came down. And he offered to make the coffee while I went and got to work. And because I spoke to Penrose that day and worked on a story for the BBC about the story I told about him crossing the street, about where that flash came from that led to the paper that led to the Nobel Prize. So it was really exciting.
What an experience.
Yeah.
So which famous physicist are you going to biographize next?
It's an interesting thing, because it is a major emotional journey to get that far inside someone else's life on a professional basis. I don't know if I'm going to be up for another biography.
I'm just saying maybe they'll win the Nobel Prize.
Maybe.
So I think in terms of what you were just saying, you didn't have a good ending for the book, or you didn't, there's no satisfying note to end on in some ways without this prize. As I was thinking about that as I was reading the book, I think maybe one of the reasons that is that much of Penrose's life's work was trying to reconcile, and has been trying to reconcile, general relativity and quantum mechanics.
Right.
And that's something that many physicists around the world, including many of the physicists in this building at Perimeter, are trying to do using a variety of approaches. You mentioned string theory. There's others, of course. And your book really does an amazing job of building that tension between these two very different theories. General relativity, something that is very concerns the very big, and something that concerns the very small, and that tension has not been resolved.
Yeah.
How did you feel knowing that at the end you'd still have to leave this big mystery of this man's life work unsolved? Right.
So that is a difficult thing, and it's connected to another difficult thing, which is that you can never, if you really want to capture someone's life, you're also never finished with that. Like you're never going to get to a point where you think, okay, I got everything. I got all the important stuff. So I think one of the lessons for me personally that I took from that unsatisfying resolution is something that I've noticed with Penrose, but with many, many other scientists as well, not just physicists, but people in all kinds of academic disciplines. I often think about the scientist's temperament. And we talk, like there are lots of obvious things. You need to be smart. You need to be dedicated, diligent, rigorous, skeptical, all of those sorts of things. But there is something that many, many scientists have that I admire and try to emulate, which is a willingness to be part of a journey that began long before they came on the scene, and that may not be resolved until long after they're gone, and maybe resolved never. And yet, you're willing to devote your life to those questions, your whole career. And that is something that I try to accept. I told you about my issues with mortality. Well, I like to try to accept that not just scientists, but that people, all people, are part of a longer journey than just their lifetime.
It's a beautiful note to end it on. Thank you so much, Patchen. This has been a great conversation.
Thank you.
Thank you. So now we have a little bit of time for questions from the audience. So if you have a question for Patchen about the book or about anything we discussed, please feel free to make your way to the microphone up on the stairs just over there. If you're not able to make your way to the microphone, you can raise your hand and we'll try to get a microphone to you. I think we have, while we get set up, I will ask one of the questions from our online audience. So I think that, let's see. I'm just trying to get my feed refreshed here. All right. Did Roger Penrose ever suffer from imposter syndrome?
What a great question. Not exactly, but one of the things that I tried to document in the book was his journey from when he was a kid in, let's say, London, Ontario, where his family lived during World War II, when he first discovered his love of mathematics, because he had a great teacher who saw in him some possibilities and gave him more time to work on things, and it was really an eye-opening time for him, to his decision in the last years of grade school to drop biology, thereby giving up on the family expectation that he would have a medical career, in pursuit of mathematics, knowing that he loved it, and then, against his parents' wishes, studying mathematics in university, all the time having some doubts about whether that was a valuable thing to do with his life or not. So it wasn't imposter syndrome, but it was some question about what his life, what his career was going to be about, to then making the shift from pure mathematics to mathematical physics, and then kind of growing into the community of elite physics, and starting to think not just that maybe he found his thing, but maybe he was really good at it, and then maybe thinking maybe he was really great at it, and then perhaps that he was one of the greatest at it. That was not a fast journey, and that was not something that was assumed from the beginning. So there was definitely, he wasn't always the person as we see him today.
All right. Go ahead.
Just an observation. There are probably several of us in the audience who were here when Penrose gave a lecture here. And what I recall is just what you were talking about, transparencies. He showed up, it was an overhead transparency projector, and he had a stack of transparencies 2 feet thick, flops them down, starts going through them. Time passes, and somebody, I think, gave him a signal, and he went halfway down the stack and pulled out another transparency halfway down the stack.
Amazing.
So it was kind of interesting.
His lectures are performances. They're just fantastic.
Okay, we have another question up here.
Hi, I was just wondering, how would you have ended the book if he didn't win the Nobel Prize? Because I know you said that affected how it ended a lot.
Well,
so
I think the actual ending of the book goes beyond the Nobel Prize anyway. And what the conclusion of the book is, I center on a theme that runs throughout the book, which is that people aren't puzzles that can be solved the way physics problems can be solved, and that there's always another piece, or a piece that used to fit that doesn't fit anymore, and that is an endless process. So I wanted to allow readers to kind of sit with that unsatisfying understanding of how complex a human life is. So I probably would have ended with that as well, just without the excitement of a Nobel Prize.
Thank you.
All right, we have some more questions coming from the audience, but we have one more from online. If he had to choose another career, what do you think Penrose would choose?
Oh, I don't even know if I could. I mean, he did almost have a medical career.
Okay.
That was the plan until he made some course choices. He is a musician. He's an artist. He has lots of other talents, but who knows?
Mm-hmm.
Who knows?
Go ahead.
Hi. 6 years working on a biography with Penrose. Do you feel that you developed some kind of relationship with him?
I mean, it's definitely an intense, moving process to get to know someone that well. It is, but I mean, I approach this as a journalist as well. So it's always all of our interactions were in the service of my ultimately writing the book. So it's an odd relationship, definitely intense, but always with the biography in mind.
Thank you.
Yeah, I guess I was going to ask you if you would get him at the microphone here, or oh, please. Sorry, the microphone isn't on, Evan.
I actually have like 2 questions, but the first is pretty simple.
Okay.
Did Roger Penrose create the Penrose diagram?
Yes.
I watched a video like about space-time curving and a bit about the Penrose diagram, and can you tell me a bit more about the Penrose diagram?
Yeah, sure. So we it's something I didn't get a chance to talk about tonight, but I love talking about it. So Penrose diagrams are they use a type of geometry called conformal geometry, and what they allow you to do is take an infinite universe, infinite in space and infinite in time, and draw a diagram of it on a single page. And the way you do it is you draw a diamond. The vertical axis is time, and the side-to-side is an axis that represents all 3 spatial dimensions. And then he drew these very graceful curves that followed a special type of geometry that allowed you to map the way light might move through the universe, or the way a black hole might affect the way space and time change shape in this really simple way. And it was is one of those creative, original, beautiful ideas that is something that we non-scientists can look at and appreciate, but that also allowed people to talk about space-time in a different way and debate different ideas in a way that was much easier. It was like creating a visual vocabulary for talking about the universe. So I love them too.
What a wonderful question to end on. Okay, so that concludes our event with Patchen Barss this evening. Let's everyone thank Patchen for this enlightening conversation.